Hello everyone, I am Sunil Kumar, and in this video I am going to talk about some of the important topics. So first we are going to talk about multi-programming of the operating system. So multi-programming is basically two types, non-preemptive, and one is preemptive, or you can say multitasking, or you can say time sharing. What do you mean by non-preemptive? Let me discuss this. First, what is non-preemptive? What is non-preemptive? So let me discuss about the non-preemptive, or you can say non-preemption. So let's suppose on CPU or running state, one process is running. Let us assume that process is P4, and P4 is running, and let's suppose he wants to complete 10 nanoseconds on CPU. That process wants to complete 10 nanoseconds on CPU. Now if it is running on non-preemption, like if this process is non-preemptive, then if any process comes into the ready states, then it may have like a high priority or low priority, but P4 will not be affected. Once P4 has started executing, then this P4 will leave CPU only after completion of this time 10 nanoseconds. That concept is called as non-preemption concept, or that process is going to be non-preemptive process. So let me explain it again. Let's suppose process P, this is you can say ready state. This is ready state, and there are two processes, P4 and P5. Let us assume. So in this case, this is CPU. Now let's suppose one process is selected based on some algorithm. Let's suppose that process is P4. That process is P4, and P4 requires 15 nanoseconds time for CPU. How much time? P4 requires 15 seconds time for execution. So now P4 has started executing. Now let's suppose P4 just has completed only 5 seconds. How much time? P4 just has completed 5 seconds. Another process comes into the ready state, let's suppose, which is P10. That process is known as P10, let's suppose. Now this process is having highest priority. According to the rules, now this process should execute onto the CPU first, then other process will execute. But because this process is running onto the CPU, in what mode? Non-preemption, or you can say non-preemptive. This process is actually non-preemptive. What is non-preemptive? Means once this process will have CPU, then this process is not going to leave the CPU until this process finishes the time. This process finishes its execution time. After completion of 15-second time only, this process is going to leave CPU. That concept is called as non-preemptive concept or non-preemption concept. Okay, let me explain what is preemption. After completion of that time, then a process leaving the CPU, that is called as non-preemption concept. Now let's suppose there are some process into the ready states. So let's say there are P4, P5, P6. There are some process, and this is CPU. Now let's suppose P6 is selected based on some algorithm. Now P6 is selected, and P6 wants to complete 10 seconds on CPU. Let us assume. So P6 is running onto the CPU. P6 is scheduled and P6 is running. Now P6 has just completed only 4 seconds. Only P6 has executed for 4 seconds. P6 has executed only for 4 seconds. Another process comes into the ready state, let's suppose, which is P8. Now P8, let us assume, we are assuming that scenario, P8 is having highest priority. It means what? Among these processes, P4, P5, P6, even though P6 has already scheduled onto the CPU, among these processes, P8 is supposed to execute onto the CPU. Means P8, because P8 is having highest priority, and that process should execute onto the CPU first. But P6 has only completed 4 seconds, but P8 cannot wait into the ready state because it is having highest priority. That is the reason CPU will be taken from the P6, even though it has not completed its time completely, because for completion of CPU time, it requires 10 seconds, but 4 seconds is only completed. But still P6 cannot continue the execution because highest priority process arrived into the ready state, and that process has to execute first. Then CPU will be taken from the P6, and this P6 will be again brought into the ready state. that activities, whatever happening, that activity is called as preemption mode. Due to preemption, that CPU has CPU is taken from the P6, so that is called as the preemption concept. Means if any highest priority process comes, then if any process which is running onto the CPU and if it is having lowest priority, then that process cannot continue the execution. That process has to be preempted, or CPU will be taken from the that process, and whoever is having highest priority process, CPU will be given to that process. So that is what the preemption concept. Okay, now next is, so let me erase this. And preemption concept is also called as time sharing, because processes are executing in time sharing modes, because P6 has executed for some amount of time, then P8 came. So because processes are executing in time sharing mode, that is the reason that preemption concept is also called as time sharing mode, and that concept is also called as multitasking. Okay, now let me discuss next: long-term scheduler, short-term scheduler, midterm scheduler. We have already discussed this in process state diagram. So what is long-term scheduler? Long-term scheduler is responsible for creating the process and for bringing the process from new state to ready state. So what is the what is the logic, what long-term scheduler does? Long-term scheduler is responsible for creating the process and bringing the process from new state to ready state. This is what the long-term scheduler. Then okay, we have done this. Now what is short-term scheduler? Short-term scheduler is responsible for selecting one of the process from the ready state based on some algorithms, based on some factors. Then one of the process will be selected and will be short-term scheduler then schedule the process into the that running state. So let me repeat it again. Short-term scheduler is responsible for selecting one of the process from the ready state and will dispatch or will schedule the process to the running state or execution state. Okay, so this is what the long-term short-term scheduler, or you can say CPU scheduler. What is midterm scheduler? Midterm scheduler is responsible for suspending the process. Why we are suspending the process? Because IO state, or you can say ready state, is not sufficient to accommodate the process. That is the reason we are suspending some of the process. So midterm scheduler is what midterm scheduler is doing. It is suspending some of the process from main memory to backing store. Then once that space is going to be free, or that IO state or ready state is able to accommodate the process again, then it is going to resume the process again. So suspending the process and resuming the process will be done by the midterm scheduler. So the midterm scheduler is responsible for suspending the process and resuming the process. So this is what about schedulers. Now next, let me explain context switching. This is also important topic. So what is context switching? Let's suppose there are two processes. P1 is the process and P2 is the process. P1 is the process and P2 is the process. Let's suppose first P1 is scheduled. P1 is scheduled. Now after completion of time, P1 is about to finish. So it will take some fraction or nanoseconds time in order to finish. So this is what the like you can say this is like it is about to finish. Maybe it requires some fraction of seconds. Then it will take again to reload the next process. Let us assume this much of time it is requiring to reload the process. Let's suppose this it is reloading P2. So what is the meaning? You can say saving the context of process, saving the context of process P1 and loading the context of process P2. So saving the context of process P1 requires some amount of time, and loading the context of process P2 requires some amount of time. That time is called as context switching. Or in simple language you can say it is requiring some amount of time to finish the process P1, and it is requiring some amount of time to start the process P2. So that time between P1 and P2 is called as context switching time. Okay, let's suppose another process is next another process is being scheduled. So process P2 is going to be terminated. So let's suppose it is this much of time it is requiring. Another process P3 is loading, so it is again recurring. So that is called another context switching. This is what another context switching. How many context switching are there? 1, 2. That is not actually context switching, because it is only requiring ending time. Now this is also not context switching, because it is requiring only loading time. Means for context switching, saving the context of one process is required and loading the context of process is also required. So how, in this diagram, how many context switching are happening? 2. So this is context switching, this is also context switching. Okay, so this is all about now saving the context of process P1 and loading the context of process P2. This will be done by the, you can say, dispatcher. So who will do this? This will be done by the dispatcher. Dispatcher. It means what? A dispatcher is responsible for performing the context switching. Context switching, who does context switching? Context switching will be done by the dispatcher. Context switching will be done by the dispatcher. Context switching will be done by the dispatcher. Okay, so we have discussed what is context switching and who will do context switching. Context switching will be done by the dispatcher. Okay, then let me talk about the CP bound process and IO bound process. What is CP bound process? Let's suppose there is a process P1. So it requires, let us assume, let's say 1000 time for CPU, 1000 second time for CPU. Means what? It wants to execute like 1000 second time on CPU, and let's say it wants to execute 1 second time on input output activity. So in order to, if you compare these two times, so it is almost negligible. Means what? A process is spending most of the times on CPU. If process is spending most of the time on CPU, that process is called as that concept is called as CPU bound process. What is CPU bound process? Means if processes are spending most of the time on CPU is called as CPU bound process. Now similarly, what is IO bound process? Now let's suppose this is let me give you the same example. Now let's suppose it requires process, let's suppose this time process P3, 1 second time, it requires 1 second time for CPU, and it requires, let's say, 1000 second for input output. So in this case, now this is negligible time. So when process spends most of the time for input output activity, that process is called as IO bound process. So this is what CPU bound process and IO bound process. So let me clear all this. Now what is dispatcher? We have already done this. So dispatcher is responsible for saving the context of one process and loading the context of another process. Now I have written one more point: multi-programming of the operating system, multi-programming of the process. What is multi-programming? Let's suppose processes are being created and processes are being loaded into the ready state. Means long-term scheduler is creating the process and long-term scheduler is sending the process from secondary memory to main memory, or you can say new state to ready state. So how many number of processes are available into the main memory? The number of processes are available into the main memory is going to be the degree of multi-programming actually. Degree of multi-programming or of the process, you can say. What is degree of multi-programming? The number of processes which are available in the main memory at any point of time. Let me repeat: the number of processes which are available in the main memory at any point of time is called the degree of multi-programming.